Look at this power tower. It is huge and infinite, but it can be solved using something called Lambert's W function. But if it were that easy, I wouldn't have made this video. There is something very wrong with particular equation. What is it? At first glance, we see an infinite power tower, a series of repeating powers. But we know that if the entire thing is 4, then so is this. This is the same power tower. Remember, there are infinitely many terms, so removing one of them makes no difference. Now, if we use our traditional methods to solve this, we easily get the answer as root 2. Wait, but it wasn't supposed to be this easy. It isn't, I assure you. What if I tell you it isn't even a valid solution? Curious now? Let's see why. Imagine we have a power tower which produces the value y. For this power tower to actually converge, we must have a solution in this form. Solve for x, and we get y raised to the power 1 upon y. Firstly, notice that this function is bounded. The power tower gave us this equation. But for any power tower to actually converge to a fixed point, it must satisfy that the absolute value of y log x should be strictly less than 1. This is called a attracting power tower. Now, using properties of logarithm and inequalities, we can establish that y is in fact bounded. What we used here is called stability at a fixed point for a power tower of this kind, and it converges only when the absolute value of the derivative is less than 1. This also puts bounds on x, since x was related to y, and numerically, we can approximate it as follows. In our case, we got the value of x as the square root of 2, which comfortably fits within the required range. But the fixed point equation, where root 2 is our desired x, actually has 2 solutions, 2 and 4. So our tower converges either to 2 or to 4. This is where the problem lies. For y equals 2, we see the convergence criterion is met, while for 4, it is repulsive and it doesn't converge. This means our power tower gave us the solution x equals root 2, but for that value, the power tower basically converges to 2 and not 4. Therefore, our tower converges to 2 and not 4. This means only one thing. Our equation never had any solutions. So I do hope you learned something. Lambert's W and other things like this are not taught usually, so power towers are rare gems. So I am trying to shed some light on this. If you did, then like the video. And if you want to support me, check out the description. Thanks for having me.